Welcome to the demo of ease.ml, a system we built to help data scientists better manage their ML workflow. In this demo, we walk through the main steps of the ease.ml process. The first step is loading the data. We recognize several types of datasets: training, validation, and test, which are the standard ones, and production data. Its role will become clear later on. To showcase a bit some of the design choices, we see that ease.ml operations are lazily evaluated by calling the eval function. Evaluation results are displayed below the Jupyter cell. Here we can see the preview of the training dataset. Operations in ease.ml are composed to form a workflow graph. It tracks the entire lineage of each operation. Overall, ease.ml manages ML workflows by managing uncertainty. Some steps inject uncertainty into our workflow and some reduce it. To start off, we use data magic to treat missing values and replace them with candidate clean values. In other words, injecting uncertainty. Now we ask the system what to do next. For this, we provide the what next command, which shows us this dialog. It says we should perform a feasibility study. This means we need to run Snoopy to estimate if our dataset is good enough to support some accuracy level that we want. For example, at least 80%. The answer is no, unfortunately. Then we ask the system what to do next. It gives us two options: clean the data or acquire more data. We go for the first suggestion and invoke cp_clean. It works by selecting a minimal subset of data that we need to clean. We have chosen to clean manually, so we are treated with this dialog for cleaning data examples. Now we can see the partially cleaned dataset. The system suggests we repeat the feasibility study. After repeating it, we see that we got a positive answer. So the system tells us to move on to the next stage, searching for the best model using AutoML. We can see how AutoML works endlessly to perform model search and tuning. We can stop it at any time, and it returns a dataset containing all the models that were tried. We select the one with the best score. This model will be our candidate for pushing into production. But first, we can try it out by making a simple prediction. Now, the what next command suggests that we test our model. We test it against the existing pool of production models that were trained earlier. We can load that pool and see it here. We select the best model from the pool. We will use this model to compare it with our candidate model. Now we will invoke the ML test operator. We specify the test dataset, the models we want to compare, as well as a test condition which we will use. After running the test, we can see that it has passed. The new model is better than the old one. This means that we can append it to the production model pool. Next, the system tells us that in order to choose the best model to deploy into production, we need to use Model Picker. Its task is to select the model from the production pool with the best performance on fresh production data that we mentioned earlier. However, since this data is unlabeled and labeling is time-consuming, Model Picker finds the minimal subset of data that we need to label in order to make the decision on which model is the best. We are given this interactive labeling dialog which we use. As a result, we are presented with the best performing model which we can now deploy to production. Finally, we can ask the system again how to move on from here. And so the never-ending data science process continues. However, with ease.ml, hopefully it will be a little less painful.